Today our topic is linked list. Before learning this video, please learn our previous video of linked list. Linked list is a very commonly used linear data structure which consists of group of nodes in a sequence. Each node holds its own data and the address of the next node, hence forming a chain-like structure. There are mainly three different implementations of linked list available. They are single linked list, circular linked list, and doubly linked list. Today we will learn operations on single linked list. In single linked list consists of some nodes which have a data part as well as an address part, that is next, which points to the next node in the sequence of nodes. The operation we can perform on single linked list are insertion, deletions, and traversals. So today we will learn some operations on singly linked list. Our first operation is insert a new node at the beginning of the linked list. Means I want to insert a particular node at the beginning of the linked list, at the starting of the linked list. So what should be the function? So how we can insert a new node at the beginning of the linked list? See here, function name is begin insert and I am passing the address of the external pointer, that is header, it is 600, and the value which is our new node info, that is the node which I want to add, that node info portion is x. Now I am declaring two variables star p and star q of struct node type, means p can hold address of any node, q also can hold address of any node. P equal to star ext means p holds value at ext. So in this figure, when our linked list is empty, that is no node is there, external pointer contains null. So what is the value of p now? Value of p is null now. And if there is one node, then external pointer contains the address of the first node, then the value of p is star ext, means that is the address of the first node. Now first, using malloc, I create one new node. So malloc allocate at the time of run size of struct node size memory chunk, means malloc allocate at the time of run struct node size memory chunk, this memory chunk, and it returns the initial address of this memory chunk and it is stored to the variable q. So what is the type of queue? Data type of queue is struct node star, means queue can hold address of any node. And here typecasting is necessary because queue is the address of the struct node type. So queue is the initial address of this memory chunk. And what is the info of our new node? I already passed this info, it is x. So q arrow info is x. Now case 1, if our linked list is empty, means if no node is there. If no node is there, then external pointer contains null. Then our node will be the first node of the linked list and it is also the last node of the linked list. To make it first node, you have to give this q the address of the new node to external pointer. Because it is the last node also, this null should be the next part of the queue. So first we have to check whether external pointer contains null or not, means whether our linked list is empty or not. How we can check? If p equals to null, p means what? P is star ext, value at ext, that is here. If it is null, then we can say that our linked list is empty. Then what you have to do? You have to give q arrow next is null, this null comes here and this q should be at star ext. Because this is the last node, so q arrow next is null and star ext equals to q. So q arrow next is null and star ext equals to q. In this way, you can add only a single node to the empty linked list. Now, case 2, not empty, means if there is an existing linked list and I want to add our newly created node at the beginning of the linked list. See, this is our existing linked list, the first node address stored in the external pointer. Now what you have to do? You have to add this node at the beginning. So first you have to give this node address, that is, this will be our first node now. So this node address will be stored at external pointer. So in place of 1000 you have to write Q. And because this will be our second node, so Q arrow next should be 1000. So Q arrow next should be 1000, that is, this one will be our second node, so 1000 will be stored here. But from where we can get 1000? We can get 1000 from external pointer, that is star ext, value at ext is 1000. But if you write Q here first, then 1000 will be erased. So first what you have to do? First you have to store the value Q arrow next. So Q arrow next is 1000, that is Q arrow next equals to P, means P equals to star ext, or you can say that Q arrow next equals to star ext, or Q arrow next equals to P, and then star ext means here you have to give Q. So see first. So Q arrow next will be 1000. So from where we can get this 1000? It is star ext or P. So Q arrow next equals to P, because P equals to star ext. So Q arrow next equals to P, and then give Q to external pointer, because this will be our first node. So first you have to store the value Q arrow next, then you have to give Q here. Otherwise, you can't get the second node address. If you give Q first here, then this 1000 will be erased. So Q arrow next equals to P. P was what? P was 1000. So first you have to store 1000 here to the Q arrow next, then give Q here, that is star ext equals to Q. But remember this sequence. If you write this line first, means if you give star ext equals to Q first, then you can't get 1000. So first you have to write this line and then this line. Remember the sequence. Our next function is delete node from the beginning of the linked list. So function name is begin delete. Here also I am passing the address of the external pointer, that is 600. P is a variable that hold address of any node. Here I am storing P equal to star ext, that is the content of external pointer. Now see, if our linked list is empty, that is case 1. If our linked list is empty, then external pointer contains null. So if star ext equals to null, or we can write, because P equals to star ext, if P equals to null, then linked list is empty, deletion not possible. Now case 2, if not empty, then there is an existing linked list and external pointer holds the address of the first node. Now if I want to delete the first node, then what you have to do? You have to delete this node, free this memory, and external pointer holds the address of the second node, that is 2000, and I have to return the info of this first node. So what should be the coding? Before that, first see the animation. Delete this node and external pointer contains 2000. So what should be the coding? So x equals to PRO info. I declare one variable x. It is integer variable because all info are integer in this linked list. So x equals to PRO info. P is 1000. So PRO info is stored in a variable x, and I am returning x, return x. Now star ext equals to PRO next means what? P is 1000. PRO next is 2000. We have to store 2000 where? To the external pointer. So from where we can get 2000? We can get 2000 at the next part of the P. So P arrow next is 2000. I stored P arrow next to star ext means here. So here it is 2000. Now free P, deallocate this memory and return X, that is return PRO info. So delete this node, it is 2000 and you have to return this info. Our next operation is I have to count the number of nodes of the linked list. Count number of nodes of the linked list. This is our existing linked list. I have to count how many number of nodes are there. So what should be the coding? Function name is count and here also I am passing the address of external pointer, that is 600. Now I declare one variable p that can hold address of any node. I give p equal to star ext, means value at ext, that is value at 600, it is 1000. Actually p holds the address of the first node. And there is another variable c, it is integer variable. I initialize c as 0, it is used for counting. So what should be the coding? Initially p is what? P is 1000 because p equal to star ext equals to 1000, so p equals to 1000. Now while p not equals to null, is p is null? No, p is not null, it is 1000. Means till the end of the linked list I have to traverse the whole linked list. P equals to p arrow next. So now the new p value is previous p arrow next, that is p arrow next is 2000. So now the new p is 2000. And C++. C++ means I increase C by 1. So value of C is 1. So P equals to P arrow next. Again from here check is P is null? No. P is 2000. Then P equals to P arrow next, also increase count. So P equals to P arrow next and increase count. So count is 2, P equals to P arrow next. Again is P is null? No, it is address of this node, that is 3000. So P equals to P arrow next and increase count. So count is 3, P equals to P arrow next. Again check is P is null? No, it is 4000. So P equals to P arrow next, increase count. Now again check is P is null? No. So P equals to P arrow next, increase count. Now see, now the P is null. If P is null, because P arrow next is null, so after that P is null here. So when P is null, this while loop, this condition is false. So I have to return the total number of count, means last value of C, it is 5. So total number of nodes in this linked list is 5. Now we will learn how to write C program to implement following operations of linked list. Begin insert, that is I want to insert a new node at the beginning of the linked list. Begin delete, I want to delete the first node from the linked list. And count, I want to count how many nodes are there in our linked list. So see the code. So this is our program. This is node structure we already discussed in our previous video. These are the prototype declaration. Now see the main. In main, I initialize external pointer as null because our linked list is empty, then external pointer contains null. And this is the index. First one is begin insert, second is begin delete, third is display, fourth is count, and fifth is exit, sixth is default. So take the choice from the user. Then I start one case structure. Case 1 is you have to call begin insert function by passing the address of the external pointer and the info. Before that, you have to take how many number of nodes user want to insert, that is n. Then I start one for loop from 0 to less than n, and I have to take each node info part, and every time I have to call begin insert function repeatedly. In case of begin delete function, here also I have to pass the address of external pointer, and this function returns the deleted node info part that is stored in the variable y, and I print y. Case 3 is the recent position, to see the recent position of our linked list. So you have to call display function by passing the external pointer address. And case 4 is to count how many number of nodes are there in linked list. So here you have to call the count function. Again you have to pass the address of external pointer. This function returns total number of nodes that is stored in the variable n, and I print n. And finally exit and default. Now see, this is our begin insert function we already discussed. Here you have to pass the address of external pointer and the value which you want to insert. This is our begin delete function. Here also you have to pass the address of external pointer. This function returns the deleted node info part. So the return type is integer. This info is stored in the variable y and I print y. And then count. Here also we are passing the address of external pointer, and this function returns total number of nodes in the linked list. So the return type is integer. This total number of nodes is stored in the variable n and I print n. And finally display function. We already discussed display function in our previous video. So consult our previous video. Now I am showing the total program. Pause this video and try to do it by your own. Node structure and prototypes. Then main function. Then begin insert function. Begin delete function. Count and display function. So when I run the program, supply your choice, begin insert. Supply the number of nodes you want to insert, say it is 5. Then supply the info of the first node, say it is 11. Second node it is 22. Third node info 33. Fourth node info say 44, and fifth node info say 55. Now I want to see our linked list. So option number 3, display. Now I want to delete the first node. So begin delete, option number 2. The deleted node is 55. Again I want to see the whole linked list. So option number 3, display. So this is our existing linked list. Now I want to get total number of nodes. So option number 4. The total number of nodes in the linked list is 5. Now exit. So these are your homework. Try to answer me in the comment section what is the correct option. Pause this video, try to answer me in the comment section. These are some interview questions of linked list. Remember, linked list is very important chapter for campusing. So try to answer this question in the comment section. I am waiting for your reply. This is your programming assignment. Write a C program to implement following operations of linked list. First begin insert, then begin delete, and then count the number of nodes in a linked list. For getting more and more updates, please like, share and subscribe my channel. That's all for today. Thank you.